Now for video 1.8, you classroom flipping pros. This one's on similar figures. We're going to meld together our knowledge of solving proportions and writing proportions. And just before we get into it, a weird picture of a cat for your entertainment. So some vocabulary you need to get down first. Similar figures are figures that have the same shape, but not necessarily the same size. So let's take, for example, a triangle. These would be similar figures. The angles are all the same, but the sides are different lengths. However, they are proportional, and that's the key about similar figures, is that they are proportional, and you need to be told that they're similar before you start solving problems using proportions. You can use proportions to find the missing side lengths in similar figures. That's what we're going to be doing today. And this symbol right here means is similar to. So when you see that in your textbook, when you see that on a test, when you see that in any notes that you're taking today, know that that means is similar to. So first of all, we need to find the length of a side. What is the length of DE? So I'm looking for this length right here. And it doesn't say this here, I forgot to write it, but this is what you would see if you were to see this in a book. Triangle ABC is similar to triangle DEF. So when you see that, you know you can use proportion to solve. So when I'm building these proportions, I need to put the same sides on the same line. Just like when we were writing proportions yesterday in class, we put the same values, money, hours, flowers, on the same lines. It's the same thing here. You have to put the same sides on the same lines. So I'm going to make this an X, my variable. I don't know it, but that's what I'm looking for, DE. So I'm going to start by writing 10 and X, because I know those have to go on the same lines in different proportions. And now my other lines have to go on the same line below that, and below the triangle that they belong to. So 10 and 16 are the same triangle. I'll put them as the same ratio. And X and 12 are the same triangle, so I'll put them on the same ratio. And all I have to do now to solve this proportion, we did it so much yesterday, is cross multiply. So I get 10 times 12, which is 120, and that equals 16x. And I'm going to divide by 16. Oops. My pen didn't work. I'm going to divide by 16 on both sides, and we get x equals 7.5. So the length of this side of the triangle is 7.5, and we found that through a proportion because these are similar figures. So this is a popular example that you see where you get a diagram and you have to answer a question based on the diagram. And this question says the sun's rays strike the building and the girl at the same angle, forming two similar triangles. So right there you see similar triangles, you know you're going to use a proportion. We need to find out how tall is the building. So I'm going to assign my variable for h is the height. That's what we're looking for. We need to find out what this side is right here. This is my h. And it looks like we have corresponding sides already that we know. So the first thing I'm going to do is take the unknown side of h and start with the tops of my two proportions. So h equals, that looks like 5 feet. The girl's 5 feet tall, and that's the side of that triangle there. So remember, same sides go on the same line. So h equals 5 feet, and we're going to put h over its corresponding side of 15 feet. Remember, same triangle, same ratio. And then this length here is 3 feet. Same triangle, same ratio. And now we're just going to cross multiply like we did before, and we get 5 times 15, which is 75, and that equals 3h. And then I'm just going to divide by 3, divide by 3. So we find out that the height of the building is 25 feet. Now, one last example for you. I just want to make sure that you really understand how we're setting up proportions and solving proportions. What is the actual distance from Jacksonville to Orlando? Use the ruler to measure the distance from Jacksonville to Orlando on the map below. So you will see problems like this where you're given a scale. I'll box that scale so you can see it. And then you're given a measurement, or you may have to measure it yourself, and you need to find out what the actual distance is. So the scale is the first ratio I'm going to start with. So 1 inch is 110 miles. Now what we don't know is the miles. So I'm going to make that M. And since we don't know the miles, the M will go on the bottom, just like miles are on the bottom in our other ratio. And it looks like that distance here from Jacksonville to Orlando on the ruler is 1 1/4 inch. So I'm going to put 1.25 inches. And now, like always, we will cross multiply. So I get 1 times M, which is just going to be M, equals 110 times 1.25, which is 137.5 miles. So we just answered the question, since M is already isolated by itself, that the distance between Jacksonville and Orlando in real life is 137.5 miles. So I know you guys have had a long weekend, but make sure that you come in on Monday with any questions that you have about the material, and you'll work in your groups to try to answer them, and I will answer them for you as well. And make sure you answer this hot question. So at an NYC Science Museum, there is a 14-foot tall model of a human heart. It is the ideal size for a person who is 170 feet tall. About what size would you expect the heart of a man who is 6 feet tall to be? So remember, when you're building your proportion, same values go on the same lines. So height of the person and height of the heart should go on the same lines, and then the same values. So the 14-foot tall model and the 170-foot tall heart person should be in the same ratio. And I will see you on Monday.